Alright, hello everyone and welcome to this video. We are going to talk about normal distribution, specifically calculating the probability of a value in a normal distribution. Now this is a really important skill. We're going to use this for a very long time. So let's make sure we practice it. Let's make sure we know how to do it. We're going to do it two ways in this video, so stay tuned. So first of all, let's look at an example of a normal distribution problem. Here's one. The length of time a person takes to cook dinner is normally distributed with a mean of 35.5 minutes and a standard deviation of 2.95. Find the probability that a randomly selected individual will take less than 30 minutes to cook dinner. And then the second part of that is this outcome unusual? So there are two parts to this problem. First of all, calculating the probability. Second of all, determining whether or not it is unusual. Now that last part is actually pretty simple to figure out, and we'll talk about how to do that shortly. But I want to point out something that's important in the wording of this problem, and that is the fact that it says it's normally distributed. Okay, so obviously you can count on every problem for this week being a normal distribution because, well, that's this week's material. But, however, in general, we can't necessarily assume it's normally distributed unless they say it. So usually they will say in the problem, it is normally distributed. And then you'll know how to approach the problem. So how do we approach these problems? Well, what we need in every normal distribution problem is a z-score. The z-score. Now remember, how do we calculate the z-score? The z-score is equal to x, which is the number they're asking us about, minus the mean, all divided by the standard deviation. Now, first of all, remember, what is the z-score? The z-score is the number of standard deviations away our value is, x, how far x is from the mean. How many how many standard deviations our number x is from the mean. Okay, and that's what we're trying to find here. Once we can find the z-score, we can find how far it is from the mean, we can figure out what percentage of the curve is to the left of this z-score. Now, we're going to talk about that in more detail in just a second. So, here's how we calculate it. X minus the mean over the standard deviation. So our x value is whatever number they're asking us for, which in this case is 30, right? They're talking about the probability that this x value is less than 30. Okay, that's an important piece there. We're looking at the probability that x is less than 30, that the time spent is less than 30 minutes. So our z-score, so z is equal to x minus the mean divided by the standard deviation. So our x is 30, so z is equal to 30 minus, and our mean from the problem was 35.5. So we're going to subtract 35.5 from our x value and divide it by our standard deviation. And our standard deviation was 2.95. Important thing to notice here, every bit of information that we need is in the problem statement itself. That's important. So we're going to divide all this by 2.95. And this comes out to, with some rounding, negative 1.86. Negative 1.86. That is our z-score. Now, the next step that we're going to do is we're actually going to look into the standard normal table to find the p-value. But before we do that, let's identify what the p-value actually is. So remember, if we look at our bell curve, we know the mean is in the middle of our standard normal distribution. Okay, so what we did is we standardized our values so that way it fits this standard normal distribution. And we know that the mean is equal to 0 here. The z-score that we have is basically the value on the x-axis or on this bottom line of our standard normal table. So I had a negative 1.86 here. So it's to the left of the mean. And what I want to know is, well, what percentage of the bell curve is above and to the left of negative 1.86? And I know I'm talking about to the left because my probability statement was x less than 30. Okay? Less than tells me I'm looking at everything to the left, right? This is an arrowhead which points to the left. So we're looking at everything to the left of the z-score which I've just calculated. So I'm looking at everything to the left of negative 1.86. And I want to know what percentage of the bell curve that represents, right? What percentage is that blue out of this whole big bell curve? I want to know about that percentage. And that percentage that I find is called the p-value, which is probability. Okay, so we need to look in our standard normal table to do that. So in our standard normal table, which is given to us in our calculator, we need to find the value negative 1.86. Okay, negative 1.86. We first look along this column here on the far left. We look for negative 1.8, which is right here. We look at this whole row, and we have to find, using the top row, where the last digit of our z-score is. So our last digit is 6, so we're looking at this here. So let's highlight this row, and let's highlight this column, which has the 6 in it. And it's just going to take a second here. It's jumping all over the place. All right, let's try that again. All right, let's highlight this, and we can see the intersection of these two is at 0.0314. 0.0314 is our p-value. What does that mean? That is 3%. That means there is a 3% probability, 3 and some change, 3% probability that someone will spend fewer than 30 minutes cooking dinner. That's pretty crazy. We were able to find that probability just by looking at this table. We calculated the z-score, we looked into the standard normal table, and found the p-value with our z-score. Now notice an important thing. See how this is shaded red here to the left of a value? That means that this table only gives us probability values to the left. There are tricks we can use to find probabilities to the right, but here we're actually working with a less than, so we're all good here. Now another way we can confirm this is the other side of our calculator has an actual calculator for us. So we can plug in the values, a mean of 35.5, a standard deviation of 2.95, and then we have to decide. The only hard thing about using this calculator is deciding which calculator is appropriate. And as we mentioned in the table, we know it's going to be this guy here on the left because we're talking about probability that it's less than a certain value, so to the left of a certain value, which is this first one here. So the x value that we're going to plug in is 30, and sure enough, we get the same probability of 3.1. Now the only difference here, it was a 0.314 on the standard normal table, 0.0314. Here it's a 0.0311. That's just because of rounding. So in general, though, the important part of this is that it's a 0.03 or 3% probability. So we found that our probability that x was less than 30 was equal to 3% or 3.1%. So that's the first part of the problem. First part of the problem was, what's the probability that x is less than 30, that someone spends less than 30 minutes cooking dinner? That's 3.1%. The second part of that question is this unusual? That's the question. Is this unusual? Now, how do we decide in probability if an event is unusual? The cutoff is actually pretty straightforward. If the probability is less than 5%, the event is unusual. It's that simple. If the probability of an event is less than 5%, we consider it unusual. So very simply, looking at our probability of 3.1, is 3.1 less than 5%? Absolutely it is. So this probability is unusual. So to recap, we calculated the z-score. We used the z-score in the standard normal table to find the p-value, which is our probability. And then we determined that it was unusual because 3 is less than 5. And any probability less than 5 we would consider unusual. So there's an example for you guys. Check back in for more. I'll see you next time.